Right, hello students. In this video, I'm going to go through two questions from assignment 2C. That is question 15 and question 21. We are on the possibility and tree diagrams chapters. Right, let's look at question 15. Question 15, there are two boxes there. Box A has 7 blue balls, 5 yellow balls. Box B has 3 blue balls and 7 yellow balls. All right, so it may sound a bit confusing. What is happening is that if you read the questions carefully, you're just going to take one ball from box A. So it can be one from the 7 blue or one from the 5 yellow. Put it in box B, mix it with the 10 balls in box B, and then from box B take another one ball at random and put it back to box A. Right, so that seems to have 3 actions going on, box A to box B and then B back to box A. All right, but when you draw the tree diagram, we don't really have to worry about all these 3 actions. We just need to worry about what happened from box A to B, and then what happened from B to A. Right, so when you draw the tree diagram, the first 2 branches were comprised of the 7 blue ball and the 5 yellow ball from box A. All right. Okay, so we're just going to concentrate from what happened from box A to box B. So there's 7 chances of you getting a blue ball to put in box B. So that will be 7 over 12. And that it's 5 over 12 chance of getting a yellow ball to put in box B. Okay, so the first part easy. Now the second part is a bit complicated because you need to take into consideration that box B has already 10 balls. So if you're going to put one blue or one yellow, one blue or one yellow from box A, put it in box B, then the number of balls in box B will now become 11. So supposing if you put one blue ball from box A right into box B originally got 3, right? If you put one more, you become 4. Okay, the yellow ball still remain at, okay, we put one blue ball into box B, so 3 plus 1 gives you 4, but the number of yellow balls in box B remain at 7. Okay, similarly, supposing if you take the yellow ball from box A, put into the box B, yellow originally got 7, right? If you put 1 inside, you become 8. The blue one remain as 3, okay, because the yellow one is the one that is being added, not blue. All right, so this is the tree diagram for part I. Right, so let's look at the part 2. So for part 2A, right, so we have the possibility diagram ready. Okay, so that's our possibility diagram. So for part 2A, what happened is that you, at the end, okay, that you want more yellow balls than blue ball. Right, so if you look at the possibility diagram, the possibility is 0. Okay, because the blue ball will be always more than the yellow ball, right? Because if you have 7 blue and 5 yellow in the beginning, at the end of the actions from A to B and B back to A, you will still get back your 7 blue and 5 yellow, which means the number of yellow ball will be less than the blue. So there's no way that you can get more yellow than blue. That's why the probability is 0. Okay, if you want to get exactly 7 blue and 5 yellow back, right? Exactly 7 blue and 5 yellow, then which branch do you think you'll be concentrate on? Yes, you will just have to concentrate on the blue, okay? Because if that say you okay, you try to imagine if you are taking from blue from box A, put in box B, you're left with 6, right? And then your box B now got 4, right? So if you want to get back 7 blue in box A, then this guy must go back to here, right? Wait, it come this way, it's 7 minus 1, give you 6. So if you want to get back 7, isn't it originally you're now left with 6, right? So 1 must come from the 4. So we have to look at the blue branch, okay, to get exactly 7 blue. So the same explanation goes for the yellow, okay? If you take 1 yellow from box A, you're left with 4, right? And where did the yellow go to? Box B, right? So to get back your yellow, you must get from the yellow, right? So therefore, the probability to get 7 blue will be 7 over 12 times 4 over 11. Look at the blue branch. And for the 5 yellow, is look at the yellow branch. Okay, so that's for part B. Now, so let's look at part C. Part C is more complicated, but it's also not difficult because we have already used the blue and the yellow one to answer B. So we can just concentrate now on the blue, yellow, and yellow, blue. So let's look at what happened at the blue, yellow. Blue, yellow means I'm looking at this one and this. All right, so let's look at the blue, yellow. So blue, yellow means originally, let's look at that. Means if you look at the number of balls in box B, it's 7. That means the what happened? That means the blue actually goes to the blue, right? That's how we get 4 over 11, right? So you are left with how many blue? You're left with 6 blue, but still 5 yellow. You understand what I mean? How you get this 4? This 4, one of them must come from your blue here, right? That's how you get 6, because 7 minus 1 gives you 6, okay? And then you want to put back, because what happened is you mix the ball in B already, you want to put back to A, right? Okay, so if you put back to A, okay, you put back to A, you put back the yellow ball you have 5, right? You look at the branch, the branch is like that, blue, yellow. So I need to take 1 ball from the yellow to put back. That's why I put the arrow there. You must take from here to put back. So if I put back the yellow ball, now the yellow ball is 5. Put back the yellow ball, I'll end up with 6 blue, 6 yellow. Okay. So that does not satisfy that exactly, that does not satisfy that the yellow ball must be half of blue, or blue must be twice of yellow. That does not satisfy. So the branch is out. Okay, we cannot consider this. This is out. So we are only left with the second branch, is yellow, blue. Okay, this guy here. Okay, so let's look at what happened here. What happened here is that you see the number of blue balls in the box B remain as 3. That means you never touch the yellow, sorry, you never touch the blue ball. You never touch the blue ball in box A. So your blue ball remain as 7. Okay, and you see your yellow ball increase, right? Your yellow ball originally got 7, now become 8. That means you must have taken the yellow ball from box A, right? So your yellow ball now is 4, right? So if you want to put back, if you want to get twice as many blue ball, means you want to get 8, 4, right? Means you need to get 1 ball from who? Yes, from the blue one. So therefore, for part C, we take 5. We take this branch. 5 out of 12 times 3 over 11. And that gives you 5 over 44. Okay, if you don't quite understand my explanation, listen to it a few times. Right, let's look at the last questions. So the last questions did not require you to actually draw a diagram, probability diagram, but I think it's good to have the probability diagram so that you can understand the situation better. So what is happening is that you have a fair die. Fair die means a different number on the 6 sides. So each side will have a unit number, 1, 2, 3, 4, 5, 6. That means the number does not repeat lah. One means one side is 1, second side is 2, third side is 3, 4, 5, that kind of thing. That's what it means by fair die. Okay, so you roll it until a 6 is obtained. Once you get the 6, that means the game stopped. So that means there are 2 possibilities, 2 outcomes. So the first branch represent the first outcome, that is you get the 6. Once you get the 6, you stop. You don't need to do anymore. The second possibility is you don't get the 6. That means you can get a 1, get a 2, get a 3, get a 4, get a 5. Then what happens? You have to roll again. So roll again. If you get a 6, you stop. If you don't get, if you get 1, 2, 3, 4, 5, then you continue. You keep rolling like that. So the probability of getting the 6, of course, is 1 out of 6 because there's 6 numbers, right? And then there's only one number that's 6, right? So probability is 1 out of 6. But the 6 numbers, 6 is out. So you remaining got 5 numbers, right? So the probability of getting a 1, 2, 3, 4, 5 will be 5 out of 6. Okay, just remember that these two probability add up must gives you 1. 1 over 6 plus 5 over 6 gives you 1. If you don't get equals to 1, that means your tree diagram is not correct. So part A, it says the game ends on the third row. Ends on the third row means first one must have failed. Second one failed, then the third one passed. Third one passed means you get a 6, which is 1 out of 6. Ends on the fourth row. Okay, same thing. First fail, second fail, third fail, fourth pass. Ends by the fourth row means maximum chances is 4. They give you 4 chances. Okay, so it could be very lucky. First chance you pass already, you get a 6. Or you're not so lucky, only second time you get a 6. Or the third times you get a 6. Or you have to use all the 4 times. Okay, this is then another way of doing it is this one. Another way of doing it is 1 minus probability of not 6 at 4 row. That means all the 4 row you never get a 6. Okay, you still get the same answer. So it's 1 minus not get the 6 means fail, 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 fail. Okay, so if you work it out, 1 minus 5 to the power of 4 over 6 to the power of 4, you get the same answer as what we have above, 671 over 1296. Okay. All right, so now let's look at the last part. So the last part, what happened is that you roll the ball, no, not the ball, sorry, roll the die. But now you want to make sure you must get 2 6, then you win the game. Previously was you roll one time, roll, and then you get a 6, then you win. Now is that you must roll, you get a 6, you're still not a winner. You must roll some more until you get a second 6. Okay, understand? Right. So find the probability that the ball ends on the third row. So ends on the third row, it could be, right, you get a 6 here. But you still cannot, you still have to continue because you must remember you must get 2 6. So third row means 3 chances. 3 chances, right? Third row. So first one, 1 over 6 means you get a 6. Okay, don't be too happy. You still have to roll some more. So the second time, you mustn't get a 6. Because if you get a 6 means you end the game already, what? Means you roll 2 times, you get 6. But you want to roll 3 times. So the second time you must fail, which is 5 over 6. And then only at the third time, then you pass. Okay, that's one possibility. Another possibility is first time you fail, second time you pass, third time you pass. Okay, so that's how you do part A. All right, part B is a bit confusing. Why confusing? Okay, the explanation is the same as what we have above. Means you can have a first time pass, 6, second time fail, third time pass. Only thing is that the second time, the number must be odd only. Sorry, the second number is not odd. The second number is very important because the second number will have to make the sum of all these 3 numbers be odd number. So what are the odd number? Odd number will be, odd is 1, 3, 5, 7, 9, 11, 13, 15, etc. Right? These are the odd number, right? Then you ask yourself, what is the possibility for my second, when I roll the second time, I must get what number? Yes, I must get a 1 because 6 plus 6 is 12 plus 1 gives you 13, right? I cannot have a 2. Imagine if you roll a 2, right? That will give you even number. 6 plus 6 is 12 plus 2 is 14. So this is out. Okay, 6, 4, 6 is also out. Okay, because that also gives you even number. So in other words, because 6 plus 6 is already an even number, you must add an odd number to get an odd number. Therefore, it can only be you roll a 6, a 1, and a 6, or you roll a 6, a 3, 6, or you roll a 6, a 5, or a 6. Okay. The second possibility is what we have done above, right? It can be you fail and then you pass. So what are the possibility for the number you fail? Again, it must be odd number. So the odd number will be just 1, 3, and 5. Same explanation as what I've done for the first case. Then you see that chances of getting a 6, of course, is 1 out of 6 because it's only 1 6. Chances of getting a 1 is also 1 out of 6. And get 6 is 1 out of 6. So they are, why times 6? Because there are 1, 2, 3, 4, 5, 6 cases. That's one way. You don't want, you can do it like that. Okay, you can do the first case. First case is 6. 6 means 1 out of 6, right? How many chances of you getting 1, 3, 5? 3 chances, so 3 over 6. And then to get a 6 again is back to 1 out of 6. Plus, second possibility, 3 out of 6 chances times 1 out of 6 times 1 out of 6. You still get the same answer. One over 36. Okay, so probably it's not an easy topic really. So if you find my explanation like first time you listen to it don't get it, please listen to it a few times. Okay, I have to trouble you to listen to it a few times, and then you can just check with me again if you still don't get it. Okay, thank you.